and welcome to High School Physics Explained. My name is Paul, and I will be going through understanding Hertz's experiment of 1887 with his discovery of radio waves. But before I start, let me draw your attention back to 1865. James Clerk Maxwell had predicted that there was a form of wave called electromagnetic wave, and he worked that out through combining a number of known laws to do with both electricity and magnetism. And in determining the velocity of this electromagnetic wave, he came up to a particular value here, which ended up being the speed of light, which was already determined through other means by a number of scientists, including Foucault and Fuseau. And as a result, Maxwell decided or determined that this electromagnetic radiation, light was just but one example of. And there were other forms of electromagnetic radiation. In fact, Helmholtz, a number of years later, actually set up a prize for any scientist who could actually verify Maxwell's predictions by discovering another form of electromagnetic radiation. So how does this work? Well, basically, we have here a charged particle, and that would vibrate a lot up and down like so. And as a result of the vibration of this vibrating particle, that would generate an electric field. But this same vibrating particle would also generate a magnetic field. So what we get here is an alternating electric field and magnetic field being generated by a vibrating particle, and those fields are perpendicular to each other. So let's now introduce ourselves to Heinrich Hertz. Heinrich Hertz in 1887 set up an experiment to show the existence of this electromagnetic wave. And what he ended up having is he set up an induction coil with these balls here which built up a large charge, and this area here would produce a small spark. And that spark, he surmised, would generate an electromagnetic wave. And because it was a fluctuating electric field and magnetic field, it had the potential to cause a charge to flow in this small gap over here. In other words, create a small spark in this receiver. In this diagrammatic version of it over here, you can see over here a simplified version of that spark generator. And what happened was it would produce a wave drawn simply like this, and a spark over here would generate a small spark over here. And as a result, that is exactly what occurred. And so Heinrich Hertz determined that there must be some sort of wave traveling between the generator over here and the receiver over here. So he did a number of experiments with this. The first thing he did was he noticed that if he were to place a sheet of metal in between, or in terms of the spark generator over here, he was able to note that that sheet of metal would reflect our little wave over like so, and as a result he showed that this wave was able to be reflected. Another thing that he was able to do is to show it refracted, and so by creating a sort of piece of triangular prism here, in this case out of pitch blende, he noticed that when he generated the spark, that spark would bend, and as a result, he would have to remove his receiver over here to pick up the signal. And as a result, he showed that it actually refracted, both properties, of course, of waves. But one of the the most important experiments that he did was he got his sheet of metal over here and he lined it up in such a way that it actually produced standing waves. And the thing is that he took his receiver and moved it along the path of where the standing waves were generated, and he noticed that he produced large sparks when at this position and no sparks here at all, and then successively large sparks, no sparks, large sparks, no sparks. And then really importantly, he was able to determine the wavelength. You see, the wavelength can be determined by this distance over here. And so that distance here over to there is actually half the wavelength of the wave. And so all of a sudden, he was able to determine the wavelength. But the natural frequency of this particular receiver was also known. He could determine that. And as a result, he was also able to determine the frequency of this wave. That, of course, leads to a very important conclusion, because the product of these can be worked out, and that gives you the speed of the wave. But most critically, he determined that that speed, it actually ended up being the value of c, 3 times 10 to the power of 8 meters per second. So now all of a sudden, he determined a wave that had the value of c, which validated Maxwell's predictions a number of years earlier. But on top of that, Hertz also made another important discovery. One of the things he noted was that the spark produced over here was particularly weak. And so he created a box with a little window, and he noticed, though, the presence of this little window actually weakened the actual spark. Removing the window made the spark much longer. So he surmised that there was certainly some sort of wave adding to the effect of this electromagnetic wave. As if to verify it, he replaced the window, instead of with glass, with quartz. And he noticed that this window had no effect on the length of the things. It actually was not a lot larger. In other words, the glass seemed to block some of the light that was generated over here by the spark. And we now know that that was the first observable evidence of the photoelectric effect. We now know, of course, is that this particular spark over here produces not only light, but also a small amount of ultraviolet light. And the ultraviolet light traveled across at the same speed, and as a result, excited some electrons on the receiver and therefore gave them a little bit more energy to move the spark, and so therefore the spark was brighter. Hertz, of course, at this stage did not know this, but he recorded his observations and certainly suggested further investigation was necessary. Unfortunately, he was still very interested in electromagnetic induction and further study of radio waves, and so he postponed that. But unfortunately, in 1894, he died, and at a very young age of 36. And his work wasn't again talked about until 1900 and 1905, particularly with Einstein's development of the photoelectric effect. I hope that gives you an understanding of Hertz's experiment and his subsequent initial discovery of the photoelectric effect. Please subscribe to my channel, and I'll see you next time. Thanks.